Have you ever thought about what actually drives advances in innovation and technology? Where do these new ideas come from? Why do we have them and why do we use them? And is technology actually connected to intelligence? Well, we're going to explore those questions and a few more coming up in a second. So stay tuned to Something to Think About. Hey everybody, today we're going to have a show today that talks about something I'm really interested in, on something to think about, something that I've been thinking about for quite a while, and I thought you probably would be interested in this as well. But I'm calling this idea novus ex natura. Now that's a fancy Latin expression that means innovation from nature. Novus is new, ex natura is from natural things or from nature. And what I'm talking about here is going to be about innovation and technology that is derived from natural things. I tend to think that that is something that is the most effective and the most efficient. But, let's get into it. So, oftentimes when I want to explore a new idea, I start with some questions. And I think that's a good practice to have. So let's first ask some questions. First, what is technology? Okay. What drives technological advancement? Do we know? Good question. Can the use of technology be a measure of intelligence? And finally, what is considered natural? And I'll use air quotes. What's natural? So we're going to ask these questions and explore some of the answers, at least what we might think are some of the answers. So let's get into it. So what is technology? We use that word a lot. It's a part of our everyday lingo. It's a part of our acronyms. We have STEM, that is science, technology, engineering, and mathematics. We talk about it all the time, but what actually is technology? We tend to think about high tech, but anything could possibly be technology. So what is it? It's a method or a process of transforming energy from one form into another. Now, as the physicist in me wants to always think of things in terms of energy. And energy itself, the idea is an artificial construct, but we use it to describe, something that we're doing or what it takes to actually do something. Because without energy, everything would be still and it would be what's called entropy would be zero and nothing would be happening. But the first law of thermodynamics says that energy cannot be created or destroyed. It can only be transformed. And so technology is the ability and the tools that we use to transform energy from one form to another. Now, here's a beautiful piece of technology, right? I really like this car. I don't have it yet, but it's beautiful. Now, what does a car do? Well, most of the time we obviously think about it taking us from one place to another. And you can see the beautiful, let me just sit here and admire this for a second. All right, I'm back. All right. So what does it do? So you have something called potential energy, which is the capability. Think of it, the capability that you have. And the kinetic energy is actually something that you do. So these are two types of energy, and where our technology is focused on turning potential energy into kinetic energy. Now, what is the potential energy? In this case, the chemical processes in the gasoline in the car is the potential energy, the explosion that happens when the spark plug ignites the fuel that is compressed in the piston and causes the piston to move, and that conjunctive movement of the pistons turns the shaft, which turns the wheels, which pushes the car, which gives us the velocity, and now you have kinetic energy. Okay? Now, there are many different types of energy. Electrical energy, there's nuclear energy, there's gravitational, vibrational, mechanical, chemical, thermal, magnetic, electromagnetic, you name it, right? That's most of them, but there are either others that I haven't mentioned. But all of it, something has to be moving in order for it to be kinetic energy. So let's just say vibrational. Vibrational energy, actually, when I'm speaking, I'm vibrating the air, and the air moves, and then it hits your ear, and some of that vibrates your eardrum, and then that in turn creates an electrical impulse that goes to your brain, and your brain translates that electrical impulse into sound that you then translate into language. All of that happens, but in the midst of all of that, energy has been transformed from one type to another. So the vibrational energy was translated into electrical energy and so forth. This is what we do, and our technologies then are things that makes these transformations. So, use this beautiful car again, right? You have the gasoline, batteries, springs, hydraulics. These are all potential energies. They store up, and they're ready to release with the right trigger. And what they translate into are velocity, which is now the kinetic energy. Velocity, the lights, the radio, the steering, the shocks, the braking. These are all actions of kinetic energy that has been inspired by the potential energy translated through the technological device. So that's how technology works. And we can make it beautiful, we can make it like this, or it could be ugly like some other car. Now, what drives technological advancement? That's the next question that we have. So let's think about this. Here's a question. Now, on this axis, you have distance that you could cover in an hour, going from 5 miles all the way to 300 miles in an hour. And here is the complexity of the technology. Now, at first, you see if I'm walking, maybe I can cover 5 miles in an hour, right? If I'm consistently walking. Now, I ride a horse, a little bit more complex, right? You have to train the horse. You have to have, a bridle and a saddle and stirrups and all that kind of stuff. So there's a little complexity in the technology, but it's not quite that complex. It's more complex than walking. So, but you can get about 10 or 12 miles out of a horse constantly moving for an hour. Now, a bicycle, maybe a little bit more, especially if you're a great cyclist. It's a little more complex than what it takes to ride a horse. You have to learn how to ride a bike. You have to have wheels and sprockets and all pedals and all the things that bicycles have. But you can travel a little bit further. Now, in a car, if you're driving at a, on a major interstate, so you're going around 65 to 70 miles an hour, you can cover 60, 70 miles in an hour. And of course, it's more complex than a bicycle. And then even further with an airplane, it can allow you to go even further. So being able to do more is one of the types of technologies, or the drivers of technology, is the ability to do more. But that's not everything. What about the energy that you expend? So here's the axis that says here's the energy that you expend. And in these same modes of travel, if I'm walking, I expend a lot of energy just to go 5 miles. And if I'm riding a horse, not so much. Bicycle, maybe a little bit more, but I get to go a little further, perhaps. In a car, I'm not expending nearly as much as I'm walking, but I do have to steer and, think and roll the windows down and things like that. So, a little bit, but you go 60 or 70 miles in an hour. But what about in an airplane going 300 plus miles per hour? Here, you can go much further, but you're using less energy. You can actually go to sleep on a plane and use as little energy as possible, but go much further. But the complexity of the technology is much higher, as you saw here. Now, so here's the conclusion that we're drawing from this, and that is that we seek to maximize the work that we can accomplish while minimizing the energy we expend while accomplishing it. You got that? So we want to do more, but cost us in our personal energy less. We want our technology to be the thing that bears the burden of the energy that has to be expended to do the job. That's a driver of technology and its advances. We want to do it better, go further, and be able to be more comfortable while we do that. Okay? Now, here's a good question, can the measure or the use of technology be a measure of intelligence? Well, we think ourselves pretty sophisticated, right? And we measure our IQs in the 100 to 200 and beyond, right? We use technology and we're sophisticated. But here's some animals that use tools and are known to use tools. And many, scientists have observed many of these animals over long periods of time in their native habitats and have found that they use tools to a certain extent. Some fascinating stories about what some of these, animals do, and you can read about them yourselves. The birds obviously build nests, but they also reason to a certain extent in order to get food. Most of the actions have to do about getting food, but these animals are known to actually use tools to a certain extent. Here's an example of one of the primates using a stick to fish for termites for food. And they realized that they had to do that in order to get what they want. So necessity, you've heard the expression that necessity is the mother of invention. Well, necessity, being able to eat and get to food sources is an important function, and so they figured out how to do it. Now, other uses of technology that have been observed have been the primates, for example, using leaves to carry water, or even as sponges and chewing up the leaves and then using that as a sponge to get water and bring water back to their homes. So there are a number of different ways, but again, it's not as sophisticated as, the way we build cities and all this complexity that we're capable of as highfalutin human beings, right? Or maybe not. All right. So, what is considered natural? Well, that's subject to interpretation. It's subject to, speculation. We can have our own and we'll use our own. So I would say that technologies that are efficient, that are effective, that are harmonious and balanced, technologies that replenish, that are replenishing, and also are sustainable. Those are the kinds of technologies that can exist in balance with our environment and therefore allow us to continue to do it. You remember, lower our energy expenditure, but allow us to do more work. That's what I would, and we can talk about this, and feel free as you see this, and you can ask questions, send me questions, and if you don't, agree with something I said, hey, send a message in and we'll talk about it at another show. Look at this. Lightning finds the best possible route to the ground. And it may not always be a straight line. And neither does a river, as you see the Nile River here. And it isn't a straight line, and although perhaps a straight line is the quickest way to the ground for a consistent speed, or to its, to their tributaries and down to its, source, from its source, but it's not always a straight line. And it's interesting to me how these appear to be very similar. This is a technology we use to generate energy. And so we dig deep into the ground, find bodies that have been, decomposed for perhaps millions of years, dig that up, and then burn it to refine it and use that potential energy that's locked into that liquid as an energy source. But this is the results, because remember, there's always losses. There's no completely 100% efficient transformation from one energy to the other, from potential energy to kinetic. There's some losses. Here are losses, and these losses go up into our atmosphere and change our environment, and thus have brought about some of the woes that we experience with global warming, climate change. You have it. And this is a great contributor, because this is pumping chemicals into the air consistently 24 hours a day, and filling our atmosphere and changing our environment, and thus not living harmoniously. Here's another picture, and this one actually, pains me, because right behind this, and what's being blocked by this plume of noxious gases, is a sustainable power source that we could utilize. For everything that we're doing with this, we could utilize that if we drove our technology in that direction. And, as we talk about clean technologies and sustainable technologies, solar power is one of those. And there it sits, but it's being blocked by this output from this device. So these are some things that, I want us to think about. Now, it's a technology is a driver for what we do, how we react, how we interact with our fellow human beings. I mean, this way that I'm communicating with you is something that, we didn't have 100 years ago, or maybe even 25 years ago. Being able to do a lot of things, there's a great benefit to that. But we also have to remember the balance that we must keep in order to sustain the environment and the world that we live in. For right now, this planet is the only one we have. And so it's important that while we are moving to make things better and to provide a better living conditions for human beings through the use of technology, it's also important for us to remember that we must take care of our planet. So I hope that this has been something that you can think about. So keep on thinking. This is Chance Glenn. See you next time. Oh, hi everybody, this is Chance Glenn. Thank you for watching the show. I hope I've given you something to think about. I want you to continue to support us and follow us. First of all, you probably see this show on YouTube, so be ready to follow it and keep up with every post that we make. We're also up on Facebook under Something to Think About. Our webpage is under the Morningbird Foundation at morningbirdfoundation.org, and you should be able to find the show there. Also, you can email us, you can post on Facebook, got a Twitter account as well. So you can communicate with us. I'll be periodically answering questions from you, so look out for that. But continue to just help us out. You can like and subscribe. That goes a long way to doing that. But most of all, we want you to keep thinking. We want you to give you something to think about. Take care.